Hey guys, and welcome back to another video on the channel. In today's video, it's going to be a little short video. We're just going to be tackling this little integral here. So this integral quite looks scary straight up, but it's actually got a really nice, neat little trick here. So basically, we're going to solve this via u substitution. And the reason we're going to do that is because we notice that this function is exactly the same as this function. So if we let one of these equal u, and you differentiate that and do a u sub, one part will cancel out. Now, it's key you choose the right one. So the reason we're going to choose this inside function here is because if we differentiate this bit here and it had like e divided by 2x, that won't cancel with that because that's being cosed. So you need to do the one that's inside the cos here. So it needs to be e to the power of 2x inside the cos. That needs to be our u. So we let u equal e to the 2x. We differentiate that because we want to replace this dx with a du. So du dx, bring the 2 down the front and don't change the power because it's an Euler. Then we rearrange this to make dx a subject. So we move this up here and move this down there. So we do a little switcheroo just there. Okay. So if we rewrite this, our du is going to be du over 2 e to the 2x equals dx. Okay. Now we're not done here yet. We've got to change our bounds as well. So the reason we've got to change the bounds is because these bounds are in terms of x. So this is when x is equal to 0, and this is when x is equal to 1. So we can just work out what u is going to be. So we'll just substitute x into here. So when x is 0, u will be e to the power of 2 times 0. So it's going to be e to the power of 0, so that's just going to be 1. When x is equal to 1, we put the 1 up there, and u is going to be e squared. Now you're probably thinking, alright, what about this bit here? Well, if you notice, that's actually u as well. So what we can do is rewrite this entire thing is, alright, this is the integral, and our new bounds are from 1 to e squared, and this can be replaced with u, cos of u, du, and what was on du? 2, and we notice that this also is u. So we can see that and that cancel. So all we're left with is we can bring this half out the front, so half of the integral from 1 to e squared of cos of u du. Now let's just bring this down here. So we have a half of our integral from 1 to e squared of cos of u du. Now all we've got to do is integrate this. So if we differentiated sine, it would turn into cos. So therefore for integrating, we go backwards. So it's going to be sine. So what we have here is sine of u. And since there's no inside function, we don't need to divide by any derivative. So this is going to be sine of u with our bounds here. And then we have this half still at the front. Now we're going to substitute the first bound in here first. So we have a half brackets sine of e squared minus, substitute the next bit in, sine of 1. Now you can't work this out in your head. You need to use a calculator. So if you use a calculator, this answer should be approximately, considering the half at the front, it should be 0.02619. Righto, that was a nice quick little video. I hope you enjoyed. Like and subscribe.